Okay, thank you everyone for being here. This is very much of a packed room. We have one chair here. If someone wants, this is yours. I'm sorry. Okay, so there's a chair to steal here. Thanks a lot for all being here, and we will present to you here more Koalas, but not in the technical details, more about how you can use it and how you can effectively transition your code seamlessly between Pandas and Apache Spark. So here we'll be doing the session, the three of us. My name is Tim Hunter. I am one of the creators of the Koalas project. And I've been working at Databricks on machine learning technology since pretty much Spark existed.
Hiya, I'm Niall Turbitt. I'm a data scientist. Hello? Yeah, there we go. Hiya, I'm Niall Turbitt. I'm a data scientist on our ML practice team at Databricks. I work between professional services and training, so developing and deploying machine learning applications at scale for our customers, as well as delivering trainings focused on data science machine learning with Spark.
I'm Brooke Wenig. I'm the machine learning practice lead at Databricks in a similar role as Niall, and I'll just be in the back TAing, so if any of you have any questions or need any help, just raise your hand, I'll be there to help you.
Cool. Thanks, Brooke. Okay, so what we wanted to cover here with you is a little bit of background about the project, and this will depend a bit on how much you already know about Pandas and about Spark. Who here has heard about Koalas already and has attended the previous talk that Takuya and I gave? Okay, a number of people. Probably like half. So what I will do is that I'll quickly present the rationale for this, but mostly I think that you are here for seeing how it works and how to get things working. So I'll go there as fast as possible. So who here would consider themselves proficient in Pandas? Okay, pretty much everybody, and this is really a talk here for you. So you are probably familiar with Pandas because you have had to analyze some data set, and these data sets were probably small enough that they were fitting in your machine or onto your development machine. And I don't need to tell you too much why Pandas is so successful. You know, it is deeply integrated into the Python ecosystem. It's very easy to get some data in, plot some data out, and do all sort of numerical analysis. Spark is very much complementary to that. Spark helps you more typically if you want to go to a large scale or to a production setting, in which you would want to work on these data sets in a streaming or large scale fashion. And it was created a bit at the same time as Pandas. So who here has used PySpark? Okay, so this is the Spark Summit, so this is pretty much expected. I'm glad to see that we're all on the same page here. So Koalas is meant to be used as a pure Python library, and Niall here will show you how you can easily import it inside an environment to use it. And really, with the aim of Koalas, we want to make sure that all the knowledge you have around Pandas on a single machine can be easily transferred onto larger data sets, and that the code base that you develop can seamlessly go between smaller data sets and larger data sets. And it is definitely picking up a lot of traction these days, mostly because it really helps you very easily go between these two technologies. So we'll cover a lot more examples. I don't want to go too much into code here, but mostly to say that the goal of Koala is to make sure the code that you have here on the left will work as you expect and will work as you expect when you have larger data sets, and that all the changes that for now that you need to do when you want to work with Spark are not necessary. If you want to have the same code as the Pandas code on the left, you see that you need to add more options about inferring schema, adding comments, and so on, which typically people don't necessarily know about. So a lot of the goals of Koalas is to make sure the default that you get are the ones you would expect out of the box, on top of having the same experience. And in Koalas, yeah, this is exactly the same output, with the advantage that when you use Koalas to do the import, the data frame you get can accommodate pretty much any scale of data set. So you'll probably ask at some point if your code is compatible. I would say at this point that it is probably going to work mostly with Koalas. We have about more than 2/3 at this point of the data frame and series API in place inside Koalas compared to the Pandas API. Same thing also for group by. And some of what we found were for now less used features, especially around the multi-index and the index part, are currently being implemented. And also you'll find a number of the usual suspects for doing quick conversions, such as the get dummies, converting to date times, and so on. These functions, you can expect them to work at any scale using the Koalas data frame. Also, we'll cover later the plotting functions and also how you can do I/O much more effectively using Koalas. In particular, if you have some large data sets with which you have had to use some Spark readers, you can reuse all these Spark readers for distributed sources without having to adapt the code too much compared to what you have with PySpark. So, is it effective? We have been working with one customer already, which has shown us some pretty good results. This is a blog post that we jointly published. Essentially, what they found when using Koalas is that they could take most of their Python code, most of the Pandas code base, do some small adaptation, small changes, so less than 1% of the code change, and they would get pretty much close to the performance they would get by the whole rewrite they had done for using PySpark. So essentially the red line here, this is the runtime they had for their particular experiments. You can see here how it is dramatically faster than what they had with pure Pandas. And at the same time, nowadays, this is the same code base that they can reuse on small samples, or that they can reuse also on the whole data set. So no need to do subsampling to just being able to use Pandas. So before we jump into the demonstration, there are a couple of points which I want really to emphasize on, and mostly to show you where the differences that you'll see between Pandas and Spark come from. Fundamentally, it goes down to, I would say, mostly to two places. One of them is that Spark is more lazy, and this transcribes into its APIs. So most of the operation that Spark does will not be done until Spark is forced to do them, such as when displaying, getting the result onto a local node, or writing the file on disk. The other operation, which is also quite different between Spark and Pandas, is that Pandas maintains a natural ordering of the rows because all the rows are put together in an array, in a list. And there is already an ordering when you do that. Spark does not have really such an ordering. Spark assumes that all the data is stored in an unordered collection, which is distributed across multiple machines. And because of that, some of the operations that you would like to be able to do that you can easily do in Pandas come with a performance penalty when you want to do them with Spark. And this is the few places where you need to make a trade-off between scaling in, scaling out, or with performance. So the second part I want to emphasize also, which is different, is the internals. If you look at how Pandas is implemented, Pandas essentially is a collection of NumPy arrays stored in a dictionary. So you can easily mutate them and make changes directly onto the dataset. Because we rely on Spark, we cannot change directly the dataset because of the immutability of the Spark data frames. So the way Koala works under the hood is by having the public notion of the public interface of a Koalas data frame, and internally it keeps an internal frame which itself is immutable and wraps the Spark data frame, and this internal frame contains all the details that right now do not associated directly inside Spark, such as extra information about the column name, which column correspond to indices, and so on. So whenever you do some operations inside Koalas, you are not, even though it looks mutable, you are not changing the dataset. Internally, Koalas will create a new immutable internal frame with these transformations. And this is the case including when you do operations that look like they're being done in place. even when you say do an operation in place, under the hood, Koalas will actually build a sequence of operation that correspond to what you want to accomplish against these internal frames. So this is what I wanted to cover, and I think now we can go more into the meat of the subject. How do you want to run the question and answer? Should we take Q&A now, or should we go later? Yeah. Does anyone has any questions so far? It's better to have this session being quite interactive.
Thank you. Actually, I didn't understand why we need Koalas, though we have the data frames from a long time, and we can actually change easily, actually, Pandas data frames into the Spark data frames and so on.
Okay. So why Koalas in the first place? The Pandas data frame and so Pandas and Spark have both of them a notion of data frame. Each of them come from a different background. Spark comes more from the distributed world and has a slightly different syntax than the Pandas data frame, which means that even though, just like for our data frame, even though you think they have the same name and a bit the same feeling, you need to do very dramatic code changes in order to achieve the same things. And Koalas brings a bridge on top of that.
Thank you for the introduction. Just a question about the performance. So you can see the drop in the slide with the bar chart. Exactly. So this is with quote-unquote big data, but how's it performing on smaller data? So do we have it the other way around? Because usually Spark is very slow on small data.
Yeah, so Spark is for small data sets. Spark is known to be pretty slow typically, and of course the question is how do we switch between the two? So right now, there are two pieces for that. One is that Koalas itself is building internally a small dataset mode in which all the operation will be done within Pandas if the dataset is smaller than a fixed number of rows, such as 10,000 rows, for example. So in this case, it is just using Pandas under the hood, no Spark, for doing these operations. That may not necessarily work on all the cases, and this is why so far for example, for this user, depending on some of the settings, they decide to use manually either directly the Pandas. So when they do an import, they import Pandas as PD, or they import Koalas for some other places. And Niall will show you how you can easily convert back and forth if you really need to know which data frame you're manipulating. So the answer is yes, you can go back and forth pretty easily, and we're working on automating under the hood this switching for you.
Yeah, now I have a question. So typically for Spark, you need to have, so to say, configuration of your cluster, so to say, to define your master and so on. But here, as I see, so you don't need to have pre-configuration, so to say, of your cluster, so you can just import your Koalas and just start to use it, yeah? How you decide, how can I specify then later, so configuration of my cluster or so?
Yeah, so yeah, of course, and I think we'll see that in the notebooks. When you import Koalas, it will look at for the default Spark context that Spark has inside a notebook. So it will import Spark, look for the default Spark context, and then communicate with this Spark context. So this is how, under the hood, it negotiates with Spark to figure out which cluster to reach. This is usually done automatically. I don't think we have an example here, but you can change that. And if you are trying things locally on your laptop, if you are just importing PySpark, by default, Spark will start using a local cluster.
Hi. So I guess you mentioned that you had 60% of the API covered. Is that about right?
Approximately, yes.
Yeah. So I guess from a sort of developer point of view, I guess you would probably run into a situation where you couldn't do something because the API was missing. Do you see that you'll eventually get all the API covered, or do you sort of view this more as a sort of gateway drug to Spark, where a data scientist who doesn't know Spark but knows Pandas can just dip their toe in it and then progress to PySpark?
Yeah, that's a great question. we will never be able to achieve full compatibility with Pandas, simply because Pandas means different things and there is no formal specification. Pandas, for most of us, means the API when you use the data frame or when you want to read data, such as read CSV. And this is a level of compatibility we want to achieve absolutely for the user. After that, if you're developing, for example, geospatial application, there's GeoPandas, which directly touches the internals of how Pandas works. And this we cannot, this is much harder to support in this situation. So the goal here is roughly, the 80-20 rule, if you want, without mentioning specifically here the percentages. We want to go as far as possible into adding all these functions without incurring a huge technical performance or technical depth on our side. And this is why I believe that for the data frame and series API, we can go to pretty much everything. In the case of indexes, it is going to be probably a bit harder to achieve that, simply because indexes allow you to do more manipulations. But if you have some specific use cases you are thinking about, please come talk to us. And also, we have open tickets where we think that the API is missing. This is going to be mostly driven on a case-by-case, on a needs basis. We do not plan to simply go by alphabetical order. It really depends on what you will want to have implemented here. So I think Niall would like to get started. So we can take some questions later afterward.
Yeah, I mean, what I'll say as well is that a lot of the questions I guess you'll have as well, we can uncover as well in the notebooks. So as Tim said, we would like to keep this as interactive as possible. So if and when you have questions, even when we're going through the notebooks, do raise your hand, and given time as well, we'll try and cover those questions as we're going through the notebooks to make it as comprehensive as possible. With that in mind, I'm going to switch across to here. Again, I want to keep this as hands-on as possible. So what I have done is I've created a couple of notebooks that I would like us to run through. Just a show of hands. Who has already signed up to Databricks Community Edition or has a current? Okay, perfect. So roughly half the room. Just to level set, so I've published these notebooks under the following bit.ly links. You can firstly download those. That's not there. If you actually navigate to bit.ly /Koalas1 SSEU, you'll find the following notebook.
Hey, Niall, can you zoom in, please?
Yeah, of course.
Thank you.
And just to level set as well, in this first notebook, what we aim to cover is purely kind of the basic functionality of the Koalas API. So comparing and contrasting against Pandas and Koalas, seeing the similarities there, but also looking at the differences, how you would do certain operations in Koalas versus how you would traditionally do it with PySpark. For those of you that haven't yet signed up to Community Edition, what it is effectively a workspace hosted environment by Databricks. It's free to sign up, albeit with limited functionality. You have 6 gigs of memory, so what we're going to look at initially to display that basic functionality is working on a relatively small data set, just step through a list of operations, comparing and contrasting. Then for the second half of our tutorial, so after we break, I'm going to go through a notebook whereby I will step us through working with a larger data set. That'll be purely kind of me demonstrating, but for this first half, I would like to keep this as kind of hands-on as possible. So to enable you guys to also go through it at the same time, if you want to get this notebook, either log into your current Community Edition or sign up to Community Edition. And I can also then step us through how we would spin up a cluster on Community Edition, and then also how to import that notebook. So the following bit.ly link will take us to the following page. If you'd like to navigate up to Import Notebook will then give us the following URL, which if you can copy and paste it, and then go into Community Edition, we can then import from there. So to show you what that looks like, And I'll give a few minutes for everyone just to kind of level set. Brooke will be going around the room as well, so I'll kind of gauge how many people up there if you want to follow along, and we can then move on with actually walking through the notebook.
And raise your hand if you need any help. Niall, Tim, and I will be walking around the room.
Yeah. So just to kind of see where we are currently, for those of us that do want to follow along, can I just get a show of hands that we have logged into Community Edition or can see this page? Okay.
Sorry, can you zoom in again?
Yeah, I'm just about to. So once in your workspace, and again, I can walk through this just so people can get up to speed, but what we will want to do is take the URL from the bit.ly link that I had posted in. If you copy and paste that, go to anywhere within your workspace, really, and what you can do is right-click within your workspace, and what you'll see is a create option and then an import option. If you go to the import option, what you'll be given is either you can import from file or you can also import from URL. If you go to URL, what you can then do is simply copy and paste. Sorry, not that one. Simply copy and paste from here. And we can put that into our URL. Just the one notebook for now. Again, in the second session, it's much more of a deep dive, and we can go through that once we come to it. For the sake of this, what we will be doing is this is very much a notebook that you can follow along. It's working with a smaller data set, whereas the second half of the tutorial, because we're limited, yeah, of course. The second tutorial will be a deeper dive analysis with a bigger data set, which we're limited by Community Edition. Can I get a show of hands of anyone facing difficulties doing that or running into issues? And can I just get a show of hands before I start walking us through how to do it? Who has been able to import it? Those of us that want to follow along. Okay, great. Again, Brooke will be walking around the room, but just for the sake of time, I'll start walking us through how we first set up a cluster with regards to installing Koalas across it, and then start going through our notebook. So once in Databricks, for those unfamiliar with it, what we can do is actually install dependencies or libraries that are not currently installed, and we can install them on our cluster. What we can do is, on the left-hand pane, what you'll see is this Clusters tab. If you navigate into our Clusters tab, you'll see the ability to create a cluster. So what we're going to do is create a cluster, number one. Then number two, we want to install Koalas on that cluster. So by clicking Create Cluster, what we can do is create our cluster name. So for this, I'm just going to call it Demo. Databricks runtime version is just the current runtime version of the Databricks cluster that we're going to spin up.
Sorry, can you zoom in? Thank you.
We're going to use 6.0 ML. And because of this is Community Edition, we're slightly limited to what other options we have. For the purposes of this demo, you can call your cluster name whatever you'd like, stick to 6.0 ML, and just create your cluster. The other thing that we want to do with our cluster is also to install Koalas, as I mentioned. Because Koalas doesn't come pre-installed in our clusters, we have to install that separately. So what we're going to do is, while your cluster is actually spinning up, you can do this. So you can click into your cluster, so within all. If you then go to Libraries, so the third tab over, Install New, you're then presented with a list of library sources that you can provide. What we're going to do is install our PyPy. Then under PyPy, you can specify either a repository or also your package. So as this is just a third-party package that we're going to be installing, we can just specify Koalas. We're also going to specify the version as well. So to do that, double equals, so make sure you have the two equals, and we're going to do not point 2.0.0. Install. And again, with Databricks, this is then going to install across your entire cluster. With the sake of Community Edition, we're only just working on our, well, we only have kind of one worker that we're working on. Anyone running into any issues with that? Brilliant. So as Tim mentioned, what Koalas strives to do is present the Pandas API in a manner that you can utilize your kind of single code, Pandas code, and convert it to distributed. So for the sake of this first notebook, what we're going to do is first demonstrate the similarities between the Pandas API and also the Koalas API. See how they're both similar, but then understand the differences between traditional PySpark API and the Koalas API. Within the notebook itself, we have the Koalas docs, and then the GitHub as well that we can go to. So our requirements, as we've just installed, so our Databricks runtime 6.0 ML, and our Koalas 0.20.0. The dataset that we're going to be using is actually a relatively small dataset. This is just entirely for the purpose of being able to run in Community Edition. The real benefits you get from Koalas is being able to utilize a distributed setting whereby you can work on large datasets, but using existing Pandas code. The data set itself that we're going to be using is from the UCI machine learning repository. For those of you that haven't come across this before, it's effectively a repository of machine learning and data science data sets. The one in particular that we're going to be looking at is a bank marketing data set, so nothing super exciting, but it actually will provide us with something to demonstrate the functionality of Koalas. The data set itself is from a Portuguese banking institution, whereby they rang up prospective bank clients to see and try to market to them whether they would subscribe to a term deposit or not. So yeah, nothing super exciting, but will provide us with a data set to display that functionality. So what we first do is we want to get that data set from the repository. So anytime you see percent and then say sh or percent something at the top of a cell within Databricks, it's something we call a magic command. Here, we can use this shell command to grab from the UCI archive, so this bank zip data, and we're going to bring it to this temporary directory. Once we have done that, we can then unzip it within that directory. And again, this exists all within the Databricks file system. Sorry, for those at the back, can you see this all right? Okay. And what we're first going to do is just have a look at the head of our data. Firstly, just to get a bit of a feel for it, see what we might need to read it in, and have a look at that CSV file. So as we can see, we have a semicolon separated file. So we're going to have to specify some kind of operation whereby we're specifying our separator as a semicolon. Just seeing what that actually looks like within the file system, we see it's a super small data set. It's only 4 megabytes in size. In terms of how you would load this with PySpark, so for those of us familiar with it, again, if you wanted to infer your schema, you could infer schema true. Header is true. We see that the first row of our CSV file is as a header. For our delimiter, we're specifying semicolon. We're also specifying quote characters. So as you see around our feature or attributes, we're seeing this quote character. Display itself is a Databricks unique function, whereby it's just a way of formatting that within the actual Databricks UI itself. So as we can see, we have our data frame. So this being a PySpark data frame, where we have our attributes: age, job, marital status, education status, and then whether that client made a term deposit. How we would load that data set with Pandas. So we give our CSV path. We say CSV path, specify our header to be the first row. Again, separator as semicolon, and we also specify that quote character. So how can we take that Pandas code? Say this was a large data set whereby we had just this on a single node. How could we then use Koalas to read that in? And the quick answer is that it's simply changing this PD to Koalas itself. So what we do is import Koalas, so import Databricks.koalas, and we give it the alias KS. Anytime you see KS is effectively like you call Pandas, so pd.readCSV, pd.dataframe. To read in that CSV with Koalas, we're passing the exact same syntax, so passing the file path, the header, the separator, the quote character. And what that is a Koalas data frame. So under the hood, it is a Spark data frame, but we have that Koalas wrapper on top of it. We can display that within Databricks itself if we just want to grab the head, and we see that we have the same data frame. Note that when you call head on a Koalas data frame, it isn't necessarily going to be the exact same as what you would have with a Pandas data frame, in the sense that Spark inherently is distributed. Therefore, you don't have that true indexing. You can enable that indexing, and it's something we'll come to later in the second part of the tutorial. But just a caveat that you will not guarantee, whenever you call head, the same head as you would with Pandas. So that's one way of reading it in. Say, for example, we had our Spark data frame. So we had defined our Spark data frame above as df. If we wanted to take that Spark data frame and convert it to a Koalas data frame, we can do this in a couple of different ways. So we can call ks.dataframe and pass in our Spark data frame. Or alternatively, you can also call the function toKoalas. So given our Spark data frame df, call .toKoalas on that, and we'll assign that to kdf. So in terms of indexing, what we're often familiar with, especially in a Pandas setting, is being able to index the actual rows of your data frame. Say, for example, I wanted to grab the fourth row of my Pandas data frame, so pdf.iloc3. Because it's 0 indexed, we're obviously taking the third. And what we can grab is the actual row itself. And this is the nuances and the differences between Pandas at times and Koalas. So if I wanted to do the exact same thing to Koalas, what I'll find is that it throws me an exception. The rationale behind this being that under the hood, it is a Spark data frame. So inherently, whenever I index, it's relying on a specific ordering to my data frame itself, which within Spark is, as you may be aware, a tricky thing because it inherently wants to be distributed. It's very tough to maintain that ordering in a distributed manner. So if I wanted to grab, say for example, the fourth row, iloc in a Koalas setting has to be specified with a slice as opposed to just a scalar value. So for example, something similar, if I did KDF, so my Koalas data frame.iloc, and pass in the slice, so up to 4, I'll be getting the first 4 rows, but I can't necessarily just index straight into that 4th row. What this is, yep.
Sorry, can you repeat it?
Oh, sorry. Is there any way if you were trying to use another function that specifically needed the 4th row, could you directly use it then in any way?
Yeah, of course. I mean, I could grab this and basically with, say for example, Spark, as you would as well, you would have to kind of do it, say a dot collect on it, and then grab the last row of that. Again, you might run into some issues if you then start trying to collect an entire, it depends on the size of the thing that you're trying to collect, but inherently ordering, given the size of your data set, could be quite difficult. We'll come again to the default index that you can specify whenever you load something in with Koalas in the second part. But again, it's something you have to be kind of cautious with, I would say. Yep.
So you may have just started answering my question, which is what's the ordering on the return from this slicing?
So Koalas, so basically there are a number of different ways that you can specify the index whenever you read it in. And again, it's something that I'd like to cover in bit of a deeper dive in the next session. But effectively, you can specify to have a specifically 1-by-1 increasing index. If you don't care about your index, you can specify it without. And again, in a distributed setting, it's going to be more computationally efficient to discard that index, but it will maintain some kind of monotonically increasing index. But if you specifically wanted to have that 1-by-1 increasing index, you can specify it, but it becomes a bit more tricky. Correct. So this is a Koalas data frame that returns. Under the hood, what it's doing is calling like a Spark limit function, whereby, say, for example, I can call df.limit4. Any other questions around that? So again, if I wanted to grab that Koalas data frame and convert it to a Spark data frame, what I can do is call the toSpark method, which will then take that Koalas data frame and give me a Spark data frame. In Spark, if I wanted to get, say, the shape, so I wanted to get the number of rows and I wanted to get the number of columns, what I would have to do really is call df.count to get the count of my Spark data frame, and then get the length of the columns attributed to that data frame. So I see there's just over 45,000 rows, 17 columns. Similarly, in Pandas, if you want to get the shape, you call, say, my Pandas data frame dot shape. With Koalas, my KDF dot shape. Then similarly, if we want to start manipulating columns, with Spark, say if I have a column and I want to do some kind of manipulation on it, what I often have to do will be import call from this PySpark SQL functions module. So say, for example, I wanted to create a new column, duration new, which takes my duration column and adds 100 to each of those duration. Duration in this context being the duration of the call in seconds. So the bank marketing call, I should say. So because a Spark data frame is immutable, what we're having to do is actually create a new data frame each time and call this withColumn function. So I have my Spark data frame dot withCall. I'll specify duration new to be the name of the new column, and then use the column method plus 100. which will give me then the duration new column, which is the duration column plus 100. And I'll see that just at the end. To do the exact same in Koalas, what I can do is exactly the same as Pandas syntax. So specifying my new column, duration new, and I can just add 100 on, like so. Filtering. So with filtering in Spark, what you have to do is you have your dataframe.filter. Again, you can use your column method. You can use similar data frame syntax, greater than or equal to 300 in this instance. If I then wanted to do the exact same with Koalas, it's the exact same syntax as you would see with Pandas, in the sense that you can call your data frame, my Koalas data frame dot duration new, and I'm going to say greater than or equal to 300. One tricky thing that we often run into with PySpark is getting the equivalent of what you would have in Pandas, which is value counts. To do so with PySpark, what you often have to do is get your data frame, group by the attribute that you want to count. So for example, for each job, I want to get the number of people that have that job. And then I also want to count it or organize it descending. So what I do to get that is my data frame.group by job count for each of those groups, and then order by the count descending. To do the same thing in Pandas, what you can simply do is, so my data frame or my series dot value counts. And it's exactly the same with Koalas. So I have my job column dot value counts. And that returns the exact same format that I would like. Group by operations. So say, for example, in this instance, I want to group by education. I want to get the average age for each of those education groups. And then I want to call this new age column average age. I would do it like so in PySpark. So group by, aggregate, select, and give it an alias. I'm going to create this second data frame just for the purposes of this, so that I can then show you how I would join those two data frames together. So in this instance, I'm going to group by education and get the maximum balance for each of those education groups. The same thing in Koalas. So what I would do, and this is again where you'll see similarities with Pandas. What I can do is call .group by education. As you see, you can pass in this index argument. So this is the same as resetting your index. I can specify asIndex false, .aggregate, and I'm going to say age and mean. Renaming the columns afterwards, just as you would with Pandas. And similarly, getting that second data frame that we did above with Spark. Yes?
Yes, so the index, right? So now you're doing a... So what would happen if you put true there?
You would have a multi-index.
Okay, all right, yeah.
So say, for example, I now have these two data frames. I want to join them together. How I would do that with PySpark. So the two data frames that I created above. And what I'm going to do is specify the attribute that I would like to join on, so education here, and specify the type of join. Similarly, with Koalas, the one slight difference here is we're going to specify merge, so just as you would with Pandas. So my first data frame, I'm going to merge it with my second data frame, again, specifying which column to join on and how you want to specify that join. If I then want to take either of those data, yep.
Sorry. Is there a concatenate option as well?
I need to double check that. I'm pretty sure there is. I'll check that at the break actually and get back to you. If we then want to take those data frames and write them out, what we can do is actually write them out as Parquet files. Yeah. Pardon? Oh, it does exist. What we can do is take our Spark data frame, write it out as Parquet format, And we can also do similarly with our Koalas data frame as well. So specifying our output path and our mode. I should also note as well that similarly to Spark, you can give it the same Spark arguments, such as the number of partitions, for example, if you wanted to specify to. And you can also specify Spark in and out arguments as to how you want to save out or write out that data frame. So I know that was a bit of a whistle-stop tour at the end, but I wanted to get through just the kind of basic functionality there so that in the second half we can do a bit of a deeper dive to how you would work with a larger data set, but also how you would build kind of an end-to-end exploratory data analysis of your given data set. And then what we're also going to look at, and something that I find is particularly useful, is be able to apply custom functions to the actual grouping of your data. So the classic .groupby.apply my function, for example, to each of those groups. And we'll see how that works in a kind of context of using Spark under the hood. So if I know we've run slightly over there, but if you want to come back in 5-10 minutes or so, we can dive into the second session.
All right, thank you, everybody. Please give a round of applause to Tim and Niall. And I do want to give a shout out to the open source team. They are so responsive. I don't think I've ever had an issue stay open for more than 2 weeks. So if there's some functionality that you want in Koalas, just file an issue and they'll respond to you within 24 hours in most cases.
Great. I think I'll get started into the second session. Do we have any new people here that weren't here for the okay, perfect. Just to bit of kind of level set. So what we did in the first session was cover some of the basic functionality of Koalas. What we're going to do in this second session is have a bit of a deeper dive, how you would use Koalas to firstly import a much larger data set. The problem with Pandas that you'll often run into is if you try to import a data set on a single node that exceeds the memory within that machine, what you're going to do is run into an out-of-memory issue. What we can do is get around that with Koalas. So if you would like to follow along, and I will caveat this with the fact that you won't be able to run this, as I'm basically I'm connecting to the actual data set itself, which is 14 gigs. You're not going to be able to have 14 gigs on Community Edition. But if you would like to have the code, more than welcome to download the notebook from this bit.ly link. You can also import it into Community Edition for the sake of those newcomers. Community Edition, as I mentioned previously, is Databricks hosted environment which is free to sign up to, albeit it's limited in scope of functionality and then also actual memory that you can use. You can import this notebook, but again, you won't be able to actually run the code itself because you won't have access to the data set, but I feel like actually having that code itself will be beneficial for you to actually use in the future. So setup is purely for demonstration purposes in the sense that I'm bringing in a large data set, I'm caching it. It's something that to prevent the demo gods from striking me down.
Yeah, this data set might crash CE.
So, as I mentioned, what we're going to be doing is a bit of a deeper dive. The data set that we're working with is a bit more contextually local to here. So it's from observation.org. And what it is a nature data set recording the occurrence of flora and fauna, so plant and animal occurrences in the Netherlands. And it's recorded by over 80,000 volunteers across the country. So it's very much encouraging this concept of citizen data scientists. And upon researching kind of what data set would be interesting to use, I started coming across a lot of articles around kind of green initiatives, around encouraging biodiversity. So I thought it would be a nice combination of capturing that concept of citizen data science, so collecting your own data, analyzing data locally by volunteers, but also exploring is there increasing biodiversity, seeing whether those green schemes that have been initiated by the Dutch government have actually led to anything. So what we'll be covering is, firstly, loading the data. So I'll be demonstrating how you can load this relatively large data set. So it's 14 gigs in size, as I mentioned. We're going to do some exploratory data analysis. So using those kind of pandas plot functions that we are used to doing so with pandas. Then going to do a bit of a deeper dive on analysis of bee numbers within the Netherlands. So we're often hearing about the populations of bees decreasing over the years. Is that true? And there have also been a few schemes that the Dutch government have enacted recently, and we can see if maybe those are working. And then lastly, what I'll be doing is, again, as I touched upon, using a custom function to group by different, to first group my data set and then apply a custom function to each of those groups. What we'll be doing is forecasting with Profit. I'll come a bit more to what Profit is down the line, but it's effectively a time series forecasting library that was released by Facebook a few years back, and it's super useful when you come to actually doing forecasts. So again, what I'll be using is the most recent version of Koalas. This version was actually released yesterday. As Brooke mentioned, the people working on this are super productive. So they're rolling out releases every 2 weeks. So first, looking at my data set, and again, I'm using this %fs command in Databricks. For those that haven't seen it before, %fs is a magic command, fs being the file system within Databricks. And here we have larger. Yeah. And here we can see our CSV file split up into a number of parts. So each of these parts being one chunk of our 14 gig data set. If I want to see just the original size of the file, what I'm doing is just grabbing each of those individual part files, summing them up, and we can see, 14.5 gigs. So number one, loading my data. Say, for example, I want to do this in Pandas. What I have to do is start importing this glob module, and then concatenating together all of those different parts. I'm not actually going to run this. What happens is it'll run for 10 minutes and then throw an out-of-memory error. Again, a demonstration that if I go to load this and I'm effectively loading this to my driver, if I'm doing so with Pandas, I will crash that driver because of the size of my the driver that I have. What I can do is just load one of those part files, so just loading a sample. So just pd.readcsv. And grab the head of it. And this is our first sample of what our data set looks like. So we see each has an ID. And what we have is effectively a recording of the different kingdom, phylum, class. So say, for example, this is some kind of insect. It gives the species. And what we'll have is a count within that 5 by 5 kilometer grid that each of these volunteers are counting. They're then counting the number of individual insects, plants, flowers within that grid. And then also the state province, the exact latitude and longitude of where it was observed. So for this sample that we've loaded, what I see is it's 269,000 rows and our 50 columns. What Koalas enables me to do is load this full data set. So again, I'm just importing Koalas as KS. And there's a couple of different ways that I can load this CSV, or not necessarily CSV, but our data set. So what I'm specifying here is this default index type. And I'm specifying it to distributed. If we have a look at the Koalas docs, oh, that's not there. So you might need to remove that first what we'll see in the Koalas docs.
Can you zoom in?
Yep.
Thank you.
Is we have this default index type. And basically this specifies the index that you have associated with your Koalas data frame whenever you first read it in. And we have 3 different options that we can specify. So sequence will specify a strictly 1-by-1 increasing index. And that's implemented by this non-partitioned PySpark window function. What that can mean then is that you can have your data all within one whole partition in a single node. So with large data sets, you should very much not try to do this. Again, you run into an out-of-memory issue. The 2 distributed options that we have are this distributed sequence, which again will strictly implement a 1-by-1 increasing sequence in a distributed manner, I should say. So it is being implemented across your cluster. Or if you don't care about an index, what you can specify is just distributed. So it will, under the hood, use PySpark's monotonically increasing ID function in a distributed fashion. So it will be strictly increasing, but you won't necessarily have that 1-by-1 increasing index. I'm not going to run the cell, as I want to show you another option that we have available to us with Koalas. So whilst I could specify my default index type to be distributed, if I don't care about my index, I can specify just read CSV, read in the entire directory of those CSV part files. But one other option that I have available with Koalas is the ability to also read in delta tables. So Brooke actually touched upon this morning during the keynote, whereby we can read straight from a delta table. So if you have optimized your delta table, what we can do is read it in a much more efficient manner than just strictly reading from a CSV. So we've read in that entire data set, called head on it. Again, the same kind of attributes that we saw above. And what we can do is, as we had with our pandas, so we can call .shape, we can call .shape on our entire Koalas data frame. So where we had 269,000, I think it was, rows, we now have our full data set of 26 million, or 26.8 million rows. So we have observations, 26 million of them. If we wanted just to grab those columns, we can call our Koalas data frame .grab columns. And we can now start having a look at how we would do some exploratory data analysis. So exactly as you would have with pandas, we have this describe method, which we can call on our data frame, which provides the number of null values, or sorry, non-missing values, our mean, standard deviation, min, max, median, upper and lower quartiles. This isn't going to be super descriptive on this data set, as a lot of the columns that we have are categorical, such as your ID, or sorry, non-numeric, such as your ID and your different classes, phylums, for example. So our ID, which is a number, isn't going to make a lot of sense, but we have our individual counts. If we wanted to check the number of null values in each of our columns, what we can do is similar to pandas, .isNA.sum, which will give us then each individual column and the number of null values in each of those columns. So as we can see, there are some columns where all rows have null values. So occurrence status, coordinate precision, elevation, for example.
And again, cycling back to our value count. Say, for example, we have our kingdom attribute. We want to see how many distinct kingdoms are there. But we also want to get that as a percentage. Again, this isn't overly interpretable. I mean, we have these bacteria which make up a tiny, tiny amount of our kingdom. So let's actually have a look and compare that in terms of visualization. So what we can do with our sample, and I guess people also were asking this earlier with regards to, can I use matplotlib? And we'll come to this a little bit down. But if I wanted to use my subset, so my pandas data frame, and I wanted to make a bar plot of each of the individual each of the individual kingdoms, again, value counting.
I got you, Niall.
Yep, just bear with me 1 second. Type, yep. If I, I can just copy paste that.
No, because it's overwritten. I think you have to go back.
Usually if I,
Can you clear state and result and run off? Is that fine?
yeah.
Okay, perfect. If you can clear state and result, then you're fine.
Sorry, just bear with me 1 second.
I would just do clear state up here.
So I can fix it if I just touch it before.
The same thing is to do that and run all. Run all stuff. Yeah. Cool. Right there. We're good. Okay, perfect.
So, just to actually show you while this runs, I can show you one I prepared earlier. So like I said, if we have that pandas data frame, we want to just make a bar plot of our kingdom attribute. What we see is that, so Animalia makes up a huge amount of what we're seeing, with plants, fungi making up the rest. And we then have this Protozoa and Chromista. But bearing in mind this is only a subset of what we've read in as a total. So what we can do with koalas is apply that across our entire data set. And what you'll notice is we now have bacteria that didn't first feature in our pandas subsample. And this again comes from stems, well, it reinforces the fact that when working on a subsample of your data, you got to be careful that you're sometimes not getting a true representation of the entire data set, which with koalas allows us to work with that entire data set. If we want to start looking at our columns in particular, what we can start to do is look at the number of unique classes. So what I see is that there's 111 unique classes. So whereas humans are within the Mammalia class, we have 111 of those.
Can you zoom in again, please?
Yep. So say, for example, I want to get the number of individual classes, get the total count of each of the individual classes, and then get the number of distinct recordings. So what I'm going to do with koalas is group by our class, again, resetting our index. aggregating our count, sum, and what we're going to do is count the number of occurrences. I'm going to then rename these columns to class. So total count, what is the total number of those classes, and what is the number of distinct recordings. What I'm then going to do is create a column which then calculates the average count per recording. So if you think in each of these 5x5 grids, what on average is the number of each classes? So what I now have is my class, my total count, number of distinct recordings, average count per each recording. And what I can do is then look at a histogram of these using .hist on my actual Koalas data frame itself. So you may be familiar with the Pandas.hist function, exact same with Koalas, albeit you're applying it to the entire data set. So what we see, we have a heavily skewed distribution in terms of those classes that have a relatively low number of average counts per recording. And we can dive into that a bit more. So we see that it's highly skewed, but what are these ones that are off to the right? What are the classes whereby we have a huge number of average counts per recording? And what we can do is grab the above data frame, so the Koalas data frame, we're sorting those values, and we can then apply these Pandas formatting functions as well. And what we see is we have this Euphoria, or sorry for any biologists in the room, Euphoria class, which has over 3,000 instances per each of those grids. And for those of you that are interested, that's starfish. So there's a huge number of starfish in some areas per grid in the Netherlands. So as I mentioned at the start, whenever we were looking at what would be interesting to cover, something that I kept coming across were these green initiatives that the Dutch government have brought in terms of increasing biodiversity and in particular increasing bee numbers within the Netherlands. So something that I wanted to drill down into was from our data set, do we see increasing bee populations? Do we see decreasing bee populations? And can we dig into that a bit more? So combining bees with some koalas. So as we would with pandas, we can filter down to Apis, which is the genus for honeybees. And we can have a look at that, whereby we're seeing each of these arthropods, insects, and then within that are honeybees. We can grab the shape of that, so we see 5,000 occurrences. And we can then see, using our Koalas functions, what dates do we have recordings. So between 1993 right up until 2018 in November. And what you'll notice is that we have these date time types. And this is another bit of functionality with Koalas that enables us to work with date time. Another bit of functionality that we have with Koalas is that we can query using SQL. So for those of us that are more used to querying with SQL, what you can do is we can pass in these external variables, such as honeybee, data frame from above. I'm going to query that with SQL, and I just want to see, for each month, how many occurrences do I have of those honeybee recordings. And what we see is that I only have 1 month whereby I have a recording for honeybees in 1993, whereas in recent years, I have full years of each month, I have recordings for honeybees. So prior to 2011, our data is going to be a bit sparse. So in terms of analysis, in terms of potentially building a model on from this, what I'm going to do is subset only after 2011. Filtering down to only those years after 2011. Again, similar syntax to pandas. And what I'm going to also do is have a look at those areas or provinces within Holland or Netherlands that have the most amount of occurrences of honeybees. So we see Zuid, Holland, has the greatest, right down to if level land at the bottom. So what we're now going to do is we're going to set this up to start doing a bit of a deeper dive. So over the course of these years, so from 2011 onwards, do we see honeybee numbers increasing, decreasing? And what we're going to do is count the total number of occurrences in each of those grids. We're going to count the number of unique recordings, so how many times these recordings have happened. And then we're also going to look into what are the average number of bees per each of these recordings and have a look at that over the years. So what we can first do, again, we're doing the same group by, we're grouping by year and month. So for each year and month, what are, sorry, just gonna have to zoom out a second. What are the individual count? Sum it up. We're going to count each occurrence. And then what we're gonna do is divide that total count by the number of recordings. What that then gives us is for each year and month, so for each month, we have the total count of honeybees, we have the number of recordings, but then we also have the average count. What I can then do is actually plot this. So I've taken this right down from my Koalas data frame, and what I can do is first create this SQL query, whereby I'm going to concatenate together my year and month. I'm creating this string, and what I can then do is Koalas toDateTime function. So having this, I can then use toDateTime, so ks.toDateTime, and what that will do is return in the format of year, month, day, and I'll create that as this year, month column. I'm going to sort those values, and then what I can then do is actually plot those. To do that with matplotlib, as I mentioned previously, what we're going to have to do is kind of collect this as some kind of list or NumPy array. So because matplotlib strictly only has to accept a certain data type, what we can do is grab this Koalas series and convert it to a NumPy array. And we're going to do that with the year, so the year, month, the total count, and the number of recordings. What I can now do is I'm just going to set up, I'm going to define this Seaborn model, or Seaborn plot, and plot both the total count and the number of recordings. So what we see is the total count each year, you have this cyclic pattern whereby each summer, as to be expected, you have this spike of honeybees. What we see for the number of recordings is that over the years, number of recordings is gradually increasing, and then from 2018 to 2019, we have this huge spike. It actually doesn't show us too much. I mean, what we can see is that the total number of recordings, so the number of volunteers or the number of times volunteers are going out, is increasing, and increasing specifically between 2018 and 2019. But we have this kind of cyclical pattern each year for the actual total count. But what does that reflect with honeybee numbers? To get a truer reflection, what you can do is actually plot then the average number of bees that you see for each of these. So to have a look at this, and what we see is that cyclical pattern again, whereby each summer we have the spike of the average number of bees per occurrence, but overall we have this downward trend of honeybees within the Netherlands, which from this data set isn't too promising, but hopefully we feel that some volunteers aren't counting too accurately. Yes? So this was from observation.org. It's yeah. Any other questions around that before we dive in a bit further? Yep.
If you do some of these steps with Apache Spark, what is the difference speed-wise?
Speed, I mean, I haven't thoroughly tested it speed-wise. Tim, would you be able to speak to that in terms of if you were to do that with Apache Spark?
Okay, I have a Mac. Which piece in particular about the optimizations?
Yeah, I mean, the thing is we've gone through a whole process.
Okay.
I mean, generally, if you were doing kind of filter group by Koalas versus Apache Spark, would you see any speed differences?
Yeah, definitely. So For all of that, it will depend on the size of the data set. If you have 1,000 rows, it will be slower in Spark. If you have a data set at the size that we're starting to use, as you were saying, just concatenating this data set blows up out of memory inside Pandas, and under the hood, it will become faster and faster as you use Spark and as you increase your data set. Simply because Spark can then leverage multiple machines, while Pandas will not be able to do that. So here, behind the scene, as Niall was showing, it is using a full cluster of machines to distribute the calculations, especially in group by that can make a dramatic difference. In terms of Koalas versus Spark, there is a little bit of performance gap here, which for any sort of reasonable use, well, actually for any use case, it's pretty much negligible. It is about of a 5-10% of a head right now, due to the fact that Koalas add a bit more introspection on the types of the data set.
Great. Just to get through the last part of this notebook, say for example, I wanted to maybe make multiple plots for certain classes at the same time, or do the classic group by .apply that you would typically see in Pandas. What I'm going to do here, as I mentioned previously, I'm going to use Profit. Profit, if you want to dive into it a bit further, is really useful time series library or time series forecasting library, which, as I mentioned, has been open sourced by Facebook. For the sake of this demo, what I'm going to do is forecast for a number of different classes. So I'm going to subset just to these 4 different classes. So insects, arachnids, Malcostra, or crustaceans, I've learned, and this final class as well. So subsetting down to these 4 different classes, ultimately with the aim of wanting to forecast the number of occurrences of these different classes going into the future. So what I'm doing, similar as before, yeah. Is in like a list.
Can you repeat the question?
So yeah, the question is, in Pandas you have the functionality of filtering by is in and then pass in a list of different things that could be contained. I'm not entirely sure if that functionality, Tim, do you know if that functionality is available?
This functionality is available at least in one of the pull requests. I believe this one has been merged. But if it has not, then please notify the developers. We'll make sure it's here. This is something I also use on my branch.
I'm not going to live test it for you. So what we're doing, same as before, I want to see what the total number of count is for each of these, and I want to get the number of recurrences as well. Same methodology as well. I'm concatenating, creating this date time column. And so what I have is for each of these classes, in each of the months, I have the number of recordings and also the total count. What I'm also going to do, which I think is actually super useful, is being able to use MLflow to track artifacts as we actually train those models. So what I'm going to do is create plots for each of those individual classes that I'm applying my function to, but I'm also then going to track artifacts that each of those forecasting models is outputting. Here is just a general MLflow setup. So it's specifying the experiment and just grabbing a couple of tokens that we're going to need to pass into our function. The forecasting function itself, and again, just kind of conscious of time, so I'm going to quickly run through it. But what we're doing is passing in these tokens, going to grab our year-month columns as my date stamp. I'm going to grab the total count. So what I'm going to do is try to predict the total count going into the future. This format is purely the kind of format that Profit expects. And what I'm going to do is specify this kind of MLflow start run. What this is doing is basically going to apply to each of my different groups this function. Under the hood, what's happening is a pandas UDF. So in Spark, for those people that are familiar with it, you're going to grab each of those individual groups, and I'm going to apply this profit forecast. So specifying my profit model, I'm going to fit I'm going to predict for future periods. So I'm going to predict 3 years into the future, so 36 months. And here is where I'm saving out those figures. So for each of the different classes, I want to save out different figures. So that function, I want to apply it to each of these individual groups. So similarly to what you would do in Pandas, what you can do is you call the data frame.groupBy, pass in the name of the attribute that I want to group by on, and then what I'm going to do is apply my forecast function from above. So as this is running, what it's doing is saving those models off. If I navigate to the path of my experiment, so here I've set my experiment. If I navigate to this, it will bring me to this page, whereby I see my 4 runs. So runs in this instance are the different classes. And if I want to investigate a bit further, so say for example, insects, what is my forecast there? What I'll see is I have this forecast plot, which has been saved out. If I just zoom out. It's not the best forecast in the sense that it's going to minus numbers, but it gives you the intuition behind how you would apply those different, your unique function to each of those individual groups. And you can also then track those, the output of those within something like MLflow. So looking at insects, number 1, I'm also recording these different component plots. And I will have the exact same for each of those individual groups. So say, for example, crustaceans. And we can again see the same forecast plots. So again, that was a bit of a whistle-stop tour of what you can do with Koalas. As Tim said, it's been actively developed bi-weekly releases of kind of additional functionalities as well. So it's a super active project. And again, this has just been one method of how you can do exploratory data analysis, how you can apply those different functions to each of the groups. But I personally think it's a super exciting project, especially for those new coming to Spark, and especially for those people wanting to take their single node Pandas code and distribute it. And if anyone has any questions, happy to take them as well.
Yeah, and we also have Tim Hunter, who's one of the original creators of Koalas, to help answer any questions.
Yep.
I'll be around with the mic. Just raise your hand.
Yeah, we can answer a few questions here. After that, we have an Ask Me Anything question in the development hall. But let's start here.
So this is the UDF stuff is very impressive. The fact that you can just push a Python function and pass it on. So how did you do that? Because I know, like, to do Pandas UDFs, you need to define the schema and all of that. So
actually, yeah. Do you want to cover that one?
I know about that because I implemented this part. So yeah, it's actually pretty straightforward in the sense that when you pass Python is a very flexible language. You can take a function object, and when you annotate some type hints to the function, then you can introspect whether the type hints are present and then map them back into the Spark types. So do essentially all the conversion that you would do manually if you were a user. This automates it under the hood.
Yep.
So just a quick follow-up in that case. Is there any thought about pushing something like that into PySpark proper? Because that would be fantastic.
Yeah, so why is it in this project and not inside PySpark? That's a good question. For now, this is considered as an API breaking change, and it depends. And also, and up to very recently, PySpark was trying to be very much compatible with multiple versions of Python. This was only added to some extent in recent version of Python 2.7 and Python 3.5 onward for its support. So this is why it hasn't been actively developed there. But there are some talks about now actually seeing the uptake of the Koalas project. There are some talks about taking some pieces which are very much relevant for everybody and moving them straight inside PySpark.
Hi, yeah, I'm just interested about the plotting. You've demoed some plotting like histograms that are kind of aggregate plots, but what about if you were to take a Koalas data frame that was billions of rows and say plot date time versus something else, does it under the hood kind of go, oh, that's too big, I'm going to aggregate it in some way so that it can plot, or does it just not work? Or
yeah, so for the plotting, it depends a lot on the kind of plot. If you're doing histogram, it will do the group by count and value count for you under the hood, assuming you don't have too many categories, of course. Otherwise, it will limit itself. For if you try to do scatter plot and you have too many points, then it is going to limit itself to a sample for now. The plotting is a bit a story that we are evolving, because we are, as you said, there is a trade-off to do between the amount of information you can display and the performance that you can expect out of that. So we would like to get more input into whether subsamples should be the default, or whether we should have a warning being the default, and so on. So if you have some thought about that, then we should discuss afterwards at the Ask Me Anything question session, if we can.
I have one more question regarding the filtering. So usually when we filter in Pandas, we have to be very careful to take a copy if we want to maintain that. So this lock and iLock, is that a problem as well in Koalas, or is it just working smoothly with the filtering, not to mess up the data?
Yeah, so Pandas, the Pandas API has evolved, especially around this notion of views, because the early the version of Pandas were greedily evaluating everything, and then it was causing some performance trouble. So the newer version, we're trying to be a bit more lazy, but then that caused some problems, especially around filtering some data, where it would not necessarily deallocate all the data that would be filtered out, or when doing updates in place. In the case of Koalas, the memory under the hood is managed by Spark, and Spark will reclaim the data that, if you chain it and if it sees that it is not being used, Spark will reclaim the memory that is not being used. Also, so far we're implementing only the modern, safer APIs of Pandas. In particular, I think it is the .ix function. So far, we're not planning to implement this one because there's a lot of way it can go wrong when you use it. So this is why we are pushing users to use the iLock and lock and the .lock function instead for doing that.
Hi, thank you for the talk, first of all. I'm interested if you consider going from using Pandas towards later on using Databricks or using Koalas. Do you have a best practice approach to do this? Because you say you don't implement the full API at the moment. Would you, for instance, recommend, or is it even possible to almost run Koalas on Pandas exclusively so that you never accidentally get out of the API restrictions that you have?
Yeah, so the story of compatibility is something that is still evolving. For now, I think we'll keep it the way it is, which is giving you a warning or errors when it is not implemented, with the idea that you can always flip back by just switching the import at the beginning, and then gradually move your code base this way. But we're looking at how we can add more warnings so that it doesn't crash directly at runtime.
All right, okay. If you have any more questions, there's an AMA downstairs for Koalas. Tim and I will be present there. And so if you have any questions, please find them and give them a round of applause for the 2 tutorials.